Hi everyone. Um, we have to do software development, which is the last part of the syllabus. We know that we have to practice a lot of pseudocode for the sake of this paper two, but software development is the last part we have to do. Now, software development, though that is the part of the syllabus we are looking at, and if you look at it closely, you saw that you will see here that. You need to understand the life cycle. So when developing a program, what are the stages? So you look at the models and you look at these three models, waterfall, iterative, and the RAD. We'll describe them briefly. It says here we should look at what really are they, and then the drawbacks and benefits as well. Then we should also look at program design, specifically there. We will need to know that you need to go through certain diagrams like the state transition diagrams and so on. And then apart from that, we also need to look at the program testing and maintenance. Now, this involves errors. Okay, how to identify these errors and how to correct the errors is a very big part of this. And then we will talk about test data, so and the test plan. So that will be the final part of it. So let's look at it. PDLC, which is Program Development Lifecycle. Okay, so when creating software, you always have to go through something that involves this ring that you are seeing on the presentation. But then these are stages. Okay, so the central model that we are looking at, which we want to talk about, is a model where you always analyze when there's a program statement, a problem statement, or there is a need to develop any software. There is first an analysis that takes place. Okay, so we'll talk about analysis in detail. There is then design. After analysis, then designing, then implementing it, then testing it, evaluating it. And this cycle continues because you are always perfecting what you have and always improving on the quality of it. Okay, so um, this is what this says, that any system development lifecycle should result in a high quality system that meets or exceeds customer expectations. Okay, so it should be finished within time, and everything that is needed is supposed to be achieved. Let's say there is a computer games firm called Electronic Crafts. How is it going to go through such a model? We are going to look at this electronic crafts. Okay, but first let's talk about the cycle. The SDLC is quite a usual thing that is always happening. And because it is a cycle, every company will always go through analysis several times. They will go through design, they will go through development of the code, and they go through the whole cycle through and through as they are trying to improve on their system. So these are examples like Windows 95 came to Windows 98, then Windows ME and XP, Vista, Windows 7, Windows 10. They always build on the previous versions to get a better version now. Look at the FIFA International Soccer, which was 95 first and 96, 97. It goes on and it has continued evolving. Okay, so with the systems development life cycle, you never just quit. You are always looking at ways to improve or surpass what you have created. Okay, but remember, we are here to look at this development cycles, and we're going to look at different ones and then compare them and look at how good they are. All right, so we start with analysis. Remember, that's the first stage. Before we come to design, we cannot design it before we analyze it. So let's look at analysis. Here, when you are given any problem, you should start off by finding out about the problem and getting an idea of what you will make to solve the problem by. So there's a detailed look at current systems, and you also establish objectives for the new system. You are also looking at, is this achievable? When you want to build anything, is it achievable? Can it be done within an agreeable time frame? So you do what is called the feasibility study. You are studying, you are analyzing if this really is something that is feasible. Is it something that you're going to go ahead and develop? Okay, so in analysis, it's really establishing something out of a problem, a statement that you have, to see if you are okay to go, or it is something that you should not think about developing. All right, so that is analysis. Okay, you find out about the problem and you start on to kind of establish the objectives for it, for developing it. All right. So in this case, we're talking about electronic crafts, a gaming firm. So it wants to create a game that will sell successfully. So it needs to see what the market wants. This is in analysis stage, isn't it? This is the first stage. So it will try to see what the market wants, whether the market wants to buy such a thing. So it will try to see what are the current wants in the market. So it will gather data such as the following: how previous similar products were sold. That is called market data. Okay. What customers are interested in. So it will conduct questionnaires and interviews to do this one. Okay. What are customers looking at? So maybe have some kind of survey done and maybe questionnaires or interviews with certain sectors of who likely to be the customers. Whether it has any code that could be adapted or reused. So is there something to build up on quickly? Okay, so they can check on their internal data. Then they will do the feasibility of making any proposed game. Is it possible within the time, and do you have the technical capacity within cost and personal limits to make the game? Is this something that is viable? Okay, so that is a very important step. All right, now we come to design. After analysis has gone through and it looks like this thing should be carried on, then there is the stage of now designing. So once we have settled on what we are going to make and the objectives for the system, we need to set about to get about now to design the components. So design is important as it allows you to start thinking about how you will make things and hopefully avoid making mistakes later. So now we are designing after we've analyzed and we've given a go ahead. So design may involve mostly the following: the user interface. How will it be? How will the customer look at the system when they see it? What will they be seeing on the screen? So you have the user interface, then the processes, what will be running in the background to have this game to work. And then you talk about storage requirements. What really will be the content of this program? This is what you are designing. Okay, so this is really important. Then after designing the program, we now have implementation. You are now coding it. You are implementing means you are making it, you are creating it. There are various ways of doing this, but we are looking at the general parts of it. So you might think that all implementation involved in creating a game. You will have to think of everything that is involved. Okay, so you would be wrong to think that implementing is just a small thing like you are only coding. No, there are many other things you have to do. Look at here. You are programming the software, okay, and that software that is going to run on that hardware. So you're also, as you are coding, you're looking at what is the suitable software for that hardware, or what hardware is going to have, looking at the software that you're going to run on it. Then you are looking at installation of the hardware and the software as well, preparing of data files. Okay, so what are the certain data files that you need to have? The data files, we mean, what are you going to keep? What will be the records and what will be the structure of that? So those are the data files and training of users. Then after that is done, you need to have a plan to train the users who have to be able to use it. Every game should come with some kind of a training that people should know how to use it. Then you write the system documentation. System documentation is because there could be certain changes that you make on the game later. So you need to have a documentation to base the changes on to know what was done, and then you look at how can you make improvements to it. So this is implementation. I'll read the last paragraph here. It says, and at the same time, make sure that the system that you build fits in with what you designed, because you're looking at the design. When you have designed your solution, you might need to choose a suitable high level programming language. All right. If you know more than one programming language, you have to weigh up the pros and cons of each one. So you look at which programming language are we going to use. Are we going to use PHP? Are we going to use Java with all its security features? You'd go for Java probably. PHP for a quick one. You think of what programming language and also what skills are needed. Then you now, since you've done the implementation, so you've actually done it, you have to go into testing. So testing, you test in various ways. You're testing whether that program works. So you first do what we call more like procedure testing. You're testing each module as it comes out, and then you test the whole system together. All right, so let's look at this. The first type of testing here we call stub testing. In this testing method, you can write a stub for each procedure, meaning you're going to test each procedure. Does it give you the outcome that you need? Okay, that is the first type of testing, which is tab testing. Is each procedure. So when you program a part of it, is it the interface you are looking at? How is the interface looking? And is this interface really interacting with the customers? Just the interface. Before you talk about other parts of the program. So you are checking each thing that the user has to do. Is it working just for that particular function, that particular procedure. So that is the first. Then there is black box testing. Now, black box testing is just what you are looking at. You are not looking at the internal working of the object. Black box testing looks at input and output. Okay, black box means you are not looking at the details inside the implementation. You are just looking at when we put in this data, do we get the output that we need? That is black box testing. Okay, so you can do black box testing by just um, giving it to someone who's going to just use it, a tester who's just going to put in for each procedure. They put in some input, and is the output the one that they wanted to have. So that is black box testing. That's the difference with white box testing, where you actually here what you are looking at is you run through a program. Okay, you are checking the coding structure that makes up that program. Okay, so you check if the different routes that it is using are okay. So you are checking through, and you are looking at having the correct output, but looking at the actual routes that each input takes for the output to be done. So that's whiteboard box. Sorry, testing. You're looking at the actual code structure. Then you also do the dry runs, which are the trace tables with different test data. So you check the algorithms by using the trace tables. So you know how to use trace tables. You have to use the trace tables to see if you're having the correct outcome. Is the data going through what is needed? Are the decisions within the algorithms correct? Do we have the input that gives us the correct output? So you are actually looking at the content, what you're putting into it, and what you're getting out of it by running trace tables. Okay, so these test methods that we've talked about are more like procedure based. So each procedure you're looking at it, but then you know that you have to look at the entire system. Okay, so you do what is called integration testing. All right. So integration testing. So I'll give you these slides on their own, but now I'm just having an overview kind of discussion. But then I'll give you the actual slides. So you do integration testing. So you individually tested the modules. Now you are joining them together to see if they interact correctly. Do they work correctly as modules together in that program? That's integration testing. Are they going to work together? It's like you build a house, then you've already tested the door, you've already tested the window panes, you've already tested the tiles, but now you've put them together. Do they really work together as a house? Then you have alpha testing. So alpha testing is where it's before beta testing. Alpha testing is in-house testing. The program is running, then you give it to testers within within your organization. They're going to test it and see if it really has the expected outcomes. Okay. Then now we have what is called acceptance testing. Um, you test. This is the testing of software by customers before sign off. Okay, so you have some customers that actually test it to accept, to say yes, actually this is doing what it's supposed to do. Okay, so that is acceptance testing, to accept it. Well, beta testing, we've seen this online. Sometimes there are programs which are released and they are still at beta testing. You kind of target the users, some users. It has already been accepted. It's actually on the market, but some people may have to sign up to accept that, okay, I will use it even if it is still in the beta testing stage. I'll use it, and then they will kind of give feedback to see if the program is running. Usually just a limited number. It's not everyone who's going to be allowed to have access at that point, but when it has gone through this, then the program is good to go and really fetch what it is meant to do. Okay, now testing strategies. So let's look at the testing strategies here. Test strategy, test plans, and test data. So during the design stage of a software project. A suitable testing strategy must be worked out to ensure rigorous testing of the program from the very beginning. So let's look at these testing. So it says here, we therefore need a test plan. So the test plan should don't just test, have a plan as you for you to test. In the first instance, an outline plan is designed. For example, flow of control. Does the user get appropriate choices, and does the chosen option go to the correct module? So you are checking the flow. Okay. Do you have, does the user have the choices that are needed, say on the interface there? Then validation of input. What if you put wrong data? Okay, so validation of input. Has all data been entered into the system correctly? All right. Um, do loops and decisions perform correctly? Is data saved into the correct files? Does the system produce correct results? Or this is what is needed in the test strategy. Now, there are three types of test data. Okay, so let's look at this situation where we are looking at students who are 11 to 16 years old in a particular registration system at a school. So these students are 11 to 16 years old. We're going to have three types of test data. First, we have the normal test data. So normal is highlighted here. Normal test data is testing using the ages within 11 to 16. For example, someone is 12 years old. Is that data, when it is entered, is it accepted in the system, okay, without errors? 13 years old, 16-year old, 14-year old, 15, this is normal data and it should work normally. Then you also have what is called abnormal data. Abnormal data is you look at data that should not be entered. For example, 45 years old person, is this going to be accepted in this school registration system, or should it say this is out of range? You've given, and this age is not accepted in this secondary school. So you call this abnormal because it's out of the age limit, 45 or 6 year old. This is a secondary school, so you don't expect someone who's 6 years old to be in it. So that is abnormal data. So you create normal data to test with, you create abnormal data to test with, and also what we call extreme data, boundary data. If we are looking at 11 to 16 years old, is 11 itself accepted and is 16 accepted? This is in the boundary of the data you need. So you try to check the actual boundary if it is acceptable as well. Okay. So when you do all these three, it should show that it is correct and therefore it should work. Okay, then the next stage now after the test is evaluation. Okay, this is the final thing that you are looking at. You evaluate and see if it all is going well. Remember, we are talking about a system development life cycle here. So if you made any mistakes or things didn't go to plan, it's best to make a note of them. The next time around, you won't make the same mistake. Okay. However, the main part of the evaluation is to reflect on how successful the operational system is. So review to confirm the new system meets the original objectives. So you check the objectives that you created at the beginning during analysis. So now you are looking at analysis versus what you have produced. Is it okay? Did you meet the objectives? Okay, then you should also identify any necessary modifications. All right, now we are going to go into the models. The models, the three of them that we talked about, the waterfall model, okay, and the one which is based on iteration, and then we'll look at the RIAD as well in our next piece of presentation.